Today I'm going to be taking you on units of storage in computing. Before we go into the main video, please you can pause this part and read through the preliminary information. It's going to be very helpful. So in this video we're going to be treating three things. Number one, the meaning of data as electronic signal. Number two, we're going to be talking about bits, that's binary digits, okay, as electronic or signals. And the third, we're going to be talking about units of data storage. Number one, meaning of data as electronic signal. Data to a computer user is usually raw fact gotten from any scenario. For instance, A, B, C, D, E, F, G, H. Okay, this is data to a computer user. So you now type A, B, A, ABBA. Okay, this is information to a computer user. I mean somebody operating the computer. So, but computers, the hardware of computers, they are electronic, so they don't understand this kind of thing. They don't understand what do you mean by ABBA, what do you mean by ABA. They do not understand it. So they do not understand text, speech, video clips, snapshots, etc. So a computer uses electronic signal to store up data in the form of bits, binary numbers. Binary digits as electronic signals. Electronic or digital signals is an electric current or electromagnetic field used to represent data. Each signal comes from a switch, semiconductor, and can only be 0 or 1. These zeros and ones are called bits. Please, may I elaborate? We say each signal comes from a switch in a circuit. Okay, the kind of circuits that computers use is a complex circuit. It's just like what you can see on the motherboard. The motherboard has several circuits, so many circuits. Let's take for instance your remote. When you press 1, how does the DVD know that you just pressed 1? It's simply because the remote has a card inside of it, a motherboard, a PCB, that processes that particular 1 into zeros and ones to make that DVD understand that okay, it is this 0000111 that combines to become 1, and I do understand it this way. And then the DVD will now show you 1, and then plays for you the first clip of audio in your memory card. Usually sequence of signals or bits, zeros and ones, is used to represent data. For example, 01000001 is the binary code for capital letter A in computer. Units of data storage. The basic unit of measuring data in computer is bit. However, a bit is just one signal. So a basic character in computer is 0, 1, 2, 3, 4, A, B, C, D, one character hash, star, at, caret. All of these characters are being stored with 1 byte. Now, and 1 byte contains 8 bits. 8 bits. It could be 0, 1, 0, 0, 0, like 5 zeros, and then one more 1. Okay, which represents capital letter A. So you can see that 8 bits actually come together to form 1 byte, and then this 1 byte is used to represent a character. So other units that we have are byte, I just explained, kilobyte, megabyte, gigabyte, terabyte. So here we can see how they are calibrated in relation to bits. 8 bits make 1 byte. 1024 bytes make 1 kilobyte. So we can say 8 times 1024 bits make 1 kilobyte. 8 times 1024 times 1024 makes 1 megabyte. 8 times 1024 times 1024 and times 1024 make 1 gigabyte. 8 times 1024 times 1024 times 1024 times 1024 makes a terabyte. And so finally, so in this video we've just learned about the units of computer storage, and we've clearly mentioned that computers do not understand characters. When I say characters, I'm talking about A, B, C letters. They also do not understand videos, audios. They are electronic machines, so they are digital. They only get to understand data in the form of 0 and 1, in the form of digits, zeros and ones. And then we went on to talk about how 8 bits make 1 byte, and how 1 byte represents 1 character in computing. And then also we talked about how the units how they are. So we said, okay, there are 8 bits that make 1 byte, and then 1024 bytes make 1 what? Kilobyte. 1024 kilobytes make 1 megabyte. 1024 megabytes make 1 gigabyte. 1024 gigabytes makes a terabyte. So here you see a keyboard electronic matrix. This is what you see when you open a keyboard. Okay, beneath the keys, when you open it, you're going to see a matrix. When we say matrix, we're talking about a circuit that has a variable, that has so many switches on it. So when you look at this matrix, you see there are no key again. There's no key again. So there's no A, there's no B, there's no C. But the computer will still understand when you press A here. Now to the computer, when you press A, there's a processor up there. By the up right, you see something there is a processor. So when you press A, that A is going to affect the circuit, and then it's going to affect the flow of electric current. And the circuit, the processor tends to know, okay, this is the switch that was pressed, and this is the value, this is the binary code we've gotten now. And then it will process it and then send it to the word processor. Okay, the processor will now say, okay, well, we just got this is A, and the processor will be faster to display for you A. It's the processor's job to say, okay, well, this is the electricity that just came from the keyboard, and then process it and then send it to what, through the video card down to what, down to the monitor, and then you see what you've typed. So on top of this one, the first picture here by your left is showing you the buttons. Okay, the buttons, the buttons on in the keyboard. That's the buttons under the first case, the button. Then the second is showing you the matrix, the actual matrix there. Okay, the buttons press, when you press the button, they actually touch the switch on the matrix, and then the processor can read it. But if you use your own hand also, sometimes it can work. Please, if you have any questions, do well to ask. It will be my pleasure to answer you. But please make sure you ask through the right channel. On your screen now, you're going to be seeing your assignment. Okay, let me read for you. What size is the text file containing? What size does a text file containing just 1 character away? 1 character away. Okay, please, you can use Google to check this out in case you cannot practicalize with your own computer. 2. A file containing a character, my name is Oko, would weigh what size of data? Okay, if you know what one character contains, you just times how many characters, and then you know, okay, this is how it contains. Number 3, 0 and 1 represent what and what? in the matrix circuit of a computer digital device? Okay, the answer to this question is in the previous is in the it's in this video. So when you go through it again, go through it over and over again, you'll be able to get the answer the answer to the last question. Well, okay, thanks. Please enjoy, stay safe, stay cool. I love you. Bye.